All right, welcome back, geometry. This lesson is actually going to focus more on biconditionals. That's meaning if-then statements. All right, a conditional statement. An if-then statement is a statement such as, if you are reading this page, then you are studying math. A statement can be written in if-then form is called a conditional statement. The phrase immediately following the word if is the hypothesis. The phrase immediately following the word then is the conclusion. All right. A conditional statement can be represented in symbols. If P, then Q, or P implies Q. We can read these two different ways. If you change the hypothesis or conclusion of a conditional statement, you form a related conditionals. This chart shows the three related conditionals: converse, inverse, and contrapositive, and how they are related to a conditional statement. So the conditional is the first one we're given. That's the statement that we're given. P implies Q. Using the given hypothesis and conclusion. We're not changing anything about it. So example, if two angles are vertical angles, then they are congruent. That would be the condition. That's the conditional. If two angles are vertical angles, they are indeed congruent because that's the definition of vertical angles. The converse would be you take the statement, the original statement, and you flip them. So you're exchanging the hypothesis and the conclusion. If two angles are congruent, then they are vertical angles. So first thing I want to do is, if two angles are vertical angles, they are congruent. That is true. Why is that true? Because the definition of vertical angles are they form congruent angles. If two angles are congruent, then they are vertical angles. Well, that is false. You can have congruent angles that are not vertical. The inverse means you take the original statement and you negate both the P and the Q. So replace the hypothesis with its negation and the conclusion with its negation. So if two angles are not vertical angles, then they are not congruent. Well, just like it was false for the converse, it's going to be false here. Two angles don't have to be vertical in order to be congruent. So we can have two angles that are congruent that are not vertical angles. So that would be false. The contrapositive is you're going to negate both statements and you're going to flip them. So you flip the hypothesis and you flip the conclusion by switching them. So what you have is, if two angles are not congruent, then they are not vertical angles. So if two angles are not congruent, then they are not vertical angles. That's actually true because all vertical angles are congruent. So if they're not congruent, they can't be vertical angles. So a conditional statement always has the same truth value as its contrapositive, and the converse and inverse always have the same truth value. If you make a compound statement from a conditional statement and its converse, you can write them as a single biconditional statement. So what that's saying is the conditional and the contrapositive are always going to be the same. If it's true, it's going to be true. If the conditional is true, the contrapositive is true. If it's false, the contrapositive is false. The converse and the inverse are always going to match up as well. They're either both going to be true or they're both going to be false. But if you get to a point where all four of them are true, then we can write them as a biconditional statement, meaning it doesn't matter how we write it, it's the same the whole way through. So we're going to see that going forward. So we're going to write a couple of examples here. Write each statement in if-then form. So I'm going to get my text box out here. So I want to write this as an if-then statement. Oops. So, it's not working. If an animal, so all apes love bananas. So if an animal is an ape, then it loves bananas. And we're not necessarily deciding if it's true or false right now. We're just taking the statement they're giving us and we're writing it as an if-then statement. So if an animal is an ape, then it loves bananas. Next one. Let's do this in green. The sum of the measures of complementary angles is 90. If two angles are complementary, then their sum is 90. So we're taking the statement here and we're making it a conditional. And then the third one, collinear points lie on the same line. So what we have is, if points are collinear, then they lie on the same line. In fact, all three of these statements and conditionals are true. But that's how you would do it. Write the converse, inverse, and contrapositive of each conditional statement. Determine whether each related conditional is true or false. If a statement is false, find a counterexample. So I'm going to start off with we'll do the converse. Actually, I'll do this. I'll do the converse in red. Converse. So the converse, if we remember the converse, going back to the front page, is, so if you live in San Diego, then you live in California. So one of the things you can do, which actually helps out, is this would be statement P, and this would be statement Q. So the converse would be if Q, then P. So we're going to just reverse that. If you live in California, then you live in San Diego. So that's our converse. Now I want to ask you, is that true or false? So if you live in California, then you live in San Diego. Well, that's going to be false, and the reason it's false is because what if I lived in Oakland? Oakland is in California, but it's not San Diego. So the converse is false. If you look, my statement though, if you live in San Diego, then you live in California, that is true. All right? So now we're going to do our inverse. And we're going to do our inverse in green. So inverse. So the inverse is not P implies not Q. So we're going to negate the first one and we're going to negate the second one. So here we go. If you do not live in San Diego, then you do not live in California. So let's talk about this. If you do not live in San Diego, then you do not live in California. Well, again, we can say, what if I lived in Oakland? This would be false. Why? Because, again, I just gave a counterexample. I can live in Oakland. Oakland is, I'm not living in San Diego, but I am living in California. So that would be false. And Oakland would be my counterexample. So our third one would be the contrapositive. So let's look at the contrapositive. All right, and our contrapositive says, if not Q, then not P. So we're going to negate the living in California. If you do not live in California, then we're also going to negate the P. Then you do not live in San Diego. And let's determine if this is true or not. So if you don't live in California, San Diego is in California, so this would be true. And that's it. That would be true. Let's look at this one. If a polygon is a rectangle, then it is a square. So P is a polygon is a rectangle. Q is it is a square. And so if a polygon is a rectangle, then it is a square would be a false statement. So now let's go in and we're going to do, our first one is going to be the converse. So the converse, if a polygon is a square, then it is a rectangle. So if it's a square, then it is a rectangle. Well, we know all squares are rectangles, so that is true. Now we're going to look at the inverse. And the inverse says, if you remember, the inverse is not P implies not Q. If a polygon is not a rectangle, then it is not a square. If a polygon is not a rectangle, then it is not a square. Well, we know all rectangles, or all squares are rectangles. So if the polygon that we've given is not a rectangle, then it is not a square. So that would be true as well. And then we're going to look at the contrapositive lastly. Contrapositive. The contrapositive would be if not Q, then not P. So if a polygon is not a square, then it is not a rectangle. And this one, a polygon is not a square, then it is not a rectangle. Not all rectangles are squares, so this is false. And that's it. That's all you guys had to do. Write them out. I did the work for you. Make sure that you're copying it down. Try your best to understand it. As we go forward, you're going to need to understand these things going forward. So good luck. Reach out if you need me. See you guys.